Lesson 12.4, simplifying rational expressions. Well, what's a rational expression? Well, first off, an expression means no equal sign. A rational expression would be something as simple as this. There's a variable on the bottom. What do we have to watch out for? Well, some of you are trying to forget it, but hopefully you do remember. The old story. Can I have a 0 on top? Yes, 0 on top equals 0. You go to the beach, you're a guy, you can wear nothing on top. Can you have a 0 on the bottom? No. You're a guy, you go to the beach, wear nothing on bottom, you get arrested. Undefined. So it's the same thing here. X cannot equal 0. How did I know that? Well, 10 times 0 is 0. That would give me a 0 on the bottom. What's going to happen today is we're going to have two problems for the price of one. You're going to have to work with the problem, but you're always going to have to think about excluded values. What are values that I'm not allowed to use? When I work with rational expressions, one of the biggest challenges that people face is that there are two separate problems here. One is, what can I not have the bottom be equal? So for example, x cannot equal 0. If I gave you a rational expression problem, I would say something like simplify it. And you'd have to mess with it and change it and do this and that. But you would also, as a second part to the problem, separate from simplifying, you would also have to say, okay, what are the excluded values? What's the excluded value here? Well, now we got to do a tiny bit of math. We say 2y plus 14 cannot equal 0. Now that's just the excluded value. I haven't solved the problem. I haven't manipulated the fraction. I would leave it exactly the same as what I got it in, but I would say, for this problem, y cannot equal -7. Why can't y equal -7? Because it would put a 0 in the denominator, and that would be an undefined problem. This one is both harder and easier. We don't have to do quite as much math as this one over here, but we do have to factor it, which some of you are still struggling with. This is an easy factoring one because it's plus plus, and there's only one thing that multiplies up to 2. So now I say that cannot equal 0. X plus 2 cannot equal 0. X plus 1 cannot equal 0. X cannot equal -2. X cannot equal -1. Have I changed this problem at all? Have I reduced it, simplified it? No. All I did was say x cannot equal -2 or -1 because they would make the problem undefined. That's all I did. Another factoring problem. Hopefully you remember. If you have no middle value and a perfect square, take the square root. X cannot equal -3. X cannot equal 3. Did not change the problem, did not solve the problem, did not mess with the problem. Just simply said, these are values that cannot be put into this. If I wrote a computer program and put this equation into the program, I would have to tell the computer, by the way, if you get an answer of -3 or 3, don't plug it in, it'll blow up the computer. Excluded values. The one step that causes so much problems because people either A, forget about it, or B, confuse doing a problem with finding the excluded values. Those are two completely, totally separate processes. Now, how do we simplify Now we're actually doing some problems. So let's simplify this. I've got an r on top and a 2 times r. They're being multiplied, so I can cancel. That's 1, that's 1. I get 1 over 2. But that's only half the problem. I also say r cannot equal what? In this case, it was 2r to start with. If r equals 0, I'd get 0 on the bottom. That's my answer. So I just did 2 problems very quickly. These are being multiplied. These are being multiplied. So I can cancel the 5s. I get x over x plus 2. Make it a habit of always putting parentheses around what's on the bottom, because it'll remind you whether or not they're being multiplied. Of course, I'm not done. X cannot equal what? Well, x plus 2, and this is from this part of the problem, not this part, because I've already simplified it. There might have been something different. X plus 2 cannot equal 0. X cannot equal negative 2. Simplified, and the excluded value introduced. Trickier one. Doesn't look like anything will cancel. Let me factor the top and see what I can pull out. I can pull out a 6. I can pull out an x squared. I'll be left with an x minus 2. Let me check that out. 6, x to the third, minus 12, x squared. Looks like I did it right. And that's over 18x squared. These are being multiplied, so I can reduce. 1 6, 3 6s, x squared, x minus 2. Again, I'd leave it in parentheses, over 3. Oh, great, there's no variable on the bottom. I don't have to worry about excluded values. That's wrong. You go back to the original problem, or what I recommend, go to the second step when it's in factored form before you did all the canceling and say, what can't I have on the bottom? This is an easy one. Whenever x is being multiplied by something, just say it cannot equal 0. This one I can't do anything with. That's done. Except I have to say y cannot equal 9. That's it. Notice I did that in my head. 9 minus 9 equals 0. Y cannot equal 9 then. This is complicated. You were warned. It gets worse. Flip the page over. Now, shockingly, things get harder. Factor. Whenever you see a trinomial. That's a trinomial, that's a trinomial, that's a trinomial, that's a trinomial. Factor them. X minus plus 10 times 1, 5 times 2. 5 and 2 works. X plus 8 times 1, 4 times 2. 4 and 2 works. These are being multiplied, so I can cancel a whole piece. I keep my parentheses just at a good habit. X cannot equal. We go to this step here before we cancel, because the original problem is what we're concerned with, not the final problem when it comes to excluded values. Cannot equal negative 4 or negative 2. You may want to pause the recording and check that problem out, and then try this one on the right. Think about it before you do it. Just factored this one earlier. It's x plus 2, x plus 1. X plus, 10 times 1, 5 times 2. 5 and 2. These are being multiplied. So cancel. I get x plus 1, x plus 5, x cannot equal. I look to this step here, the factored form, to find out what's going to cause a 0, -5, and -2. That is hard, very hard. One last set of problems. Call this recognizing opposites. It's not that hard to do. It's hard to understand. Actually, I'm going to change what I do over there because I don't like the way that problem's written. I don't think I would ever do that. X minus 12 times 1, 6 times 2, 4 times 3. 4 and 3 it is. Perfect square with no middle term. Take square root of both. Plus, minus, x. And here's the hard part. I've got a 4 minus x here. I've got an x minus 4 here. They look really close, but they're not the same. I can change this term by factoring out a negative. And I'm not even going to write the rest of it in. Let's just look at that. -1 times negative x is x. -1 times 4 is -4. So this is equivalent to this. It's the same thing. I can do it anytime I want when it helps me out, and in this case it does. Just going to write the rest of it the same way. Why did I do that? Well, these are equivalent now, and I can cancel them. That's 4 minus x. That's 4 minus x. So I'm left with -1 times x minus 3, and I'm going to write it as x plus 4. Don't forget your excluded values. Cannot equal -4 or 4. If it bothers you that I do that in my head, I apologize. You should write them out. 4 plus x cannot equal 0. X cannot equal -4. 4 minus x cannot equal 0. 4 cannot equal x. And there they are. First things first, I'm going to rewrite the top. I don't like it at all. -y squared plus 4y plus 5. And I never factor anything with a negative in the first term, so I pull a -1 out and change all the rest of them. Now I can go factoring. Y minus, y plus, 5 and 1. Minus plus, 5 and 2. Y minus 5 cancels. I get -1 times y plus 1 over y plus 2, comma, y cannot equal 5, comma, -2. If you're struggling with the factoring, strongly recommend that you go back and review the factoring notes. We're doing simple factoring. There will be no a value that does not equal 1, but it's still very challenging. Good luck. Be prepared to practice.